So welcome to Material Mantra YouTube channel. Today in this video we will be learning how we are fitting a non-linear data points. So I have a experimental data point in which the y is varying with respect to x. So plot this one first. I'm just selecting x and y axis, then I will go to this data point. Since these are experimental data points, so I am just plotting a point of y with respect to x. Today we are fitting these data points with the help of origin software. It's very simple. If you do manually, it takes a long duration of time to fit this curve. So that we'll be doing in a one click. In origin software, you have to go to analysis, here, then go to fitting, and here we have to fit a non-linear curve fit. We will be getting this pop-up window where we need to select our required input data. This should be origin basic function, and so before getting into this function we have to think about like how these data points are varying. I think these are varying in the form of a sinusoidal pattern, so that's why I am selecting a function of sine. In this origin 2021 we will be getting two options. Integration algorithm should be of two options: the Leavenworth-Marconi method, if I am not wrong in the pronunciation, or orthogonal distance regression. So if your data points are much deviating, like much scattering, it's better to use orthogonal distance regression, the pro form. This will fit the data points more accurately. I got this data point fitted with this equation. You will get a ready-made equation like kind of thing. The model is sine wave. The equation of this wave is in the form of y is equal to y naught into a plus a into sine of pi x minus xc into y divided by w. So it is in the form of this equation. The y naught value, xc value, w value are given here with error values. So it is fitted, data points fitted with a point. If you want to know like accuracy of fitting, you have to see this r square value. This is near to equal to 1, that means all the data points are fitted or covered, experimental data points are covered. Now you can use this equation for your further analysis. Thank you.